Hello, hi, greetings everyone. I hope this presentation meets you well. I am Dr. Arnold Onana. I am currently working as evaluator with the North Carolina Division of Public Health within the Cancer Prevention and Control branch. And today, like you can see on the screen in front of you, we'll be talking about correlation. I hope you've been learning lots of fun stuff. I really love statistics. It's something I love. I love to play around, and I hope you're having the same fun during this course. And I hope this course is really going to help you. And so don't hesitate to give us feedback in any way possible through questions, and we'll try to respond to you as best as we can. So, like I said, today I'll be talking about correlation, and I would like this to be as simple as possible so that when you leave this course and you go out there, it's going to be really fun for you to be using this kind of test to understand whatever data you're looking at. So, what exactly is correlation? Simply put, correlation is a statistical method that is used to assess the possible linear association between two continuous variables. So as you can see, I have isolated the keywords in this definition: linear association and then continuous variable. So yes, we're not looking at a relationship that is a curve. We're not looking at a relationship which is like cubic in nature, quadratic in nature. We're looking at a linear relationship between two continuous variables. Yes, your variables have to be continuous, unless, if not, you're going to run, let's say, in Stata, and you're going to have some outputs that are going to look strange. Um, and obviously, we are looking for a linear association. It's an association and not something else. And I really have to stress on this point: correlation is an association. And what is it not if it is only an association? So, what correlation is not is that it is not causality. Correlation does not explain causality or does not determine causality, because it's a mistake we may be tempted to make, you know, but it is only a measure of association and not measure of determining causality. It's not a loosely employed term, amongst colleagues, because, oh, there's no correlation between these or that. But in this case, we are speaking specifically of statistical correlation. So that's what correlation is not all about. So let's talk about the correlation coefficient. So in order to be able to materialize this linear association, the quantity is calculated, which is called the correlation coefficient. So in order to materialize this linear association, we calculate the correlation coefficient. And this coefficient is going to show us two things. The first thing this correlation coefficient is going to show us is the strength. It shows us the strength of this association between our two continuous variables. And then the second thing it's going to show us is the direction of this association. We are going to see in a little bit more detailed ahead what's the meaning of the strength and the direction. But like I said, it's something that you're going to calculate, and it's called the correlation coefficient. Now, concerning the strength of correlation, correlation goes from 0 to 1 for its strength, and in its direction, it is given by a positive or a negative sign. So, what am I saying? I'm technically saying that correlation, the correlation coefficient has two components to it. It has the sign that comes in front of the number. That sign could either be positive or negative, like plus or minus, and then your number is going to go from 0 to 1. So technically, correlation goes from -1 to +1. I'm going to say that again. Correlation goes from -1 to +1. So what then are we going to see? If you have your correlation coefficient lying between 0.9 and 1, positive or negative, is going to be a very strong or very high correlation. If you have a line between 0.7 and 0.9, or between negative 0.7 and negative 0.9, is going to be a high positive or negative correlation. If you have it between 0.5 and 0.7, or negative 0.5 and 0.7, that's going to be a moderate positive or a moderate negative correlation. If you have it between 0.3 and 0.5, that's going to be a low positive or a low negative correlation. And if you have it between 0.3 and between 0 and 0.3, or between 0 and negative 0.3, is going to be negligible correlation. That's just a consensus on how you can interpret your correlation coefficient. Obviously, it will depend specifically on which kind of experiment you carried out, or which kind of your data set, what exactly you were looking for. So it will depend also on the circumstances of your specific research, or your specific question, or specifically what you're seeking to answer. So I say it again, a correlation coefficient of 0 means there is no linear relationship between your two variables. And to summarize, your correlation coefficient goes from -1 to +1. I think by now that should be pretty evident and clear from what we have been discussing. So again, we have two main types of correlations that you're going to encounter out there, or that you'll be called to use. You have your Pearson's correlation and your Spearman's correlation. Pearson's correlation is used when your two values are normally distributed. So if you have values that would follow that nice symmetrical bell curve, and there are other tests that you can run to be able to make sure that the data you're looking at is normally distributed. I'm not getting into that in this video, but you can do that to make sure you can use your Pearson's correlation. Otherwise, you can use your Spearman's correlation, which is used when one of the variables is skewed, or one of them is ordinal in nature, or you have extreme values that exist, also known as outliers. So you should be able to watch for that and determine which kind of correlation you want to use to run whatever analysis you have in front of you. So your Spearman's correlation is very resistant to outliers because it uses ranks instead of just using direct values of your variables. So now we are visualizing using scatter plots correlation. So these are three scatter plots that we have of an x variable against a y variable. In the first diagram, try to guess which kind of correlation is going to be. Yes, you guessed rightly. That is a weak positive correlation. We see the dots are jumbled and, following a particular pattern. They're scattered all over in space. And then in the next one, we can see the dots are pretty much aligned, and they are rising from left to right. And in this case, it's a strong positive correlation of about plus 0.8. And you can guess, and I know you have guessed rightly, for the last one, we see it decreasing from left to right of the points, and they are pretty much aligned. You can almost draw a line, and it's easy, straightforward. So you can already tell me, and I know you had it right, a strong negative correlation of about negative 0.8. So yes, now you guys are really good in correlation, and you'll be able to sort yourself out pretty well and not make mistakes with this. So in conclusion, I can say correlation, in summary, correlation coefficients are used to assess the strength and direction of linear relationships between pairs of variables. And remember, we said the variables are continuous in nature, and the relationships identified using correlation coefficients should be interpreted for what they are. They are associations and not causal relationships. So if you have that, if it is clear in your mind, then I'm glad, and I would have achieved, and you would have achieved your purpose for listening to this lecture. Once more, thank you again, and channel all your questions through Dr. Ashish Goel. So that said, go now and correlate. Thank you.